So without any further ado, I want to introduce the next amazing speaker. We have Jason Erdreich. He's going to be speaking on design thinking everywhere, which is such a fantastic topic. Jason is a technology engineering and design educator who currently supports educators in creating exciting learning environments for their students. With experience in K-12, university, and industry across the STEM and computer science disciplines, Jason strives to make teaching in our technology advanced world more relevant and accessible for students and teachers of all levels. So, with that, welcome, Jason, and thank you so much.
Yeah, of course, Donna. Thank you so much for the introduction. Very much appreciated. And thank you to IEEE for the invite to be able to chat with all of you today about what is really one of my favorite things of all time, at least to teach with or philosophy to teach with, and that's design thinking, specifically design thinking everywhere. So let me just look over here real quick to find my slides. Let's see if this works. There we go. Fantastic. So design thinking everywhere. And as Donna said, my name is Jason Erdreich. I'm a educator, tinkerer, kind of all around maker of things. I guess to expand on that a little bit, I spent the first 10 years of my teaching career at the K-12 level, primarily at the middle school, teaching anything from biotech to robotics, a lot of different STEM subject areas in an elective environment. But I also spent quite a bit of time teaching at the elementary and high school level as well, all revolving around STEM education. But about 4 or 5 years ago, I made the transition to higher education, where I was first a professor of computer science out in New Jersey, where I'm located. And now I'm a professor for STEM education, where I'm teaching future STEM, technology, engineering, and computer science design educators at the College of New Jersey, which is a position that I thoroughly enjoy, as well as doing things like this, being able to chat with you, help other educators support their students, and also still work a little bit in industry for lots of different things. So lots of fun different things, all kind of revolving around the world of STEM concepts, engineering and design. And my classroom is always a busy place with, soldering, electronics, robotics, video production, graphic design, tinkering, making. That's kind of just what I really enjoy doing. And a huge component of this, I think the commonality between, let's say, my robotics class or my video production class or my biotechnology class was always a design thinking philosophy. And it's also one that I've been able to support educators bring into not just the STEM spaces or even, let's say, an engineering elective space, but also, let's say, an English, social studies, core art, whatever, music area as well. But before we get into design thinking, I think let's just take a kind of broader perspective at what is school, right? Or more importantly, what are the most important things that we teach our students, right? So this is debatable, and I guess we could have a little bit of a debate in the chat about what you think the most important things you teach your students are. But I guess your state or your country or your county will probably say it's the standards, it's the learning outcomes and objectives that your students need to be able to meet by the end of a certain grade band. Is probably what the state would say. The trends, those curriculum trends, those PD people like me would probably say it's STEM or STEAM or STREAM or TEAMS or DREAMS or STEM plus C, depending on which acronym you're using these days, of those key content areas and things like that. That's the most important experience that students are working with. And you as an educator is probably going to say something like the skills or the content or the experience. And those are the most important things that students go to school for, right? I personally think it's a combination of all the above, right? I definitely lean more towards the skills and the experience because of my nature and my field, but it's obviously a combination of all these things. But we also know that students, of course, go to school for a lot of things: the academics, the socialization, play, arts, right? They need to learn those key academic concepts to be able to progress through their higher educational career, depending on where they want to go. Socialization is an immensely important aspect of school, as is play. Learn how to be a person, learn how to talk to people, learn how to work in a group, learn what types of friends you like to have and how to have conversations and how to share, right? I mean, those are really important things that we have students engage with in school. And of course, then there's all the arts, whether it's the music, the arts, the performing arts, the elective art areas, whatever it might be. Let students find their passions, and maybe those passions will fuel future careers, right? So there's lots of reasons why students go to school, and there's lots of things that they, of course, obtain from school. I personally think that what we really try to do, or what we should try to do, is we should teach students how to learn at school. What I mean by that is not just provide them with the content, the academic content, things like that, but teach them how to be learners, how to figure things out, how to be lifelong learners, because all of the stuff that we teach in school is, of course, hopefully relevant and applicable to where we are today. But 10, 15 years from now, when they're out into the world, they're going to need to learn something that they didn't learn in school. Because, of course, we can't teach them every aspect of life. We can't prepare them for every component of their career. So they need to be able to figure those things out. They need to be able to figure out how to learn, how to study, how to look things up, how to obtain knowledge, and again, how to be a lifelong learner. And that is, not something that you just automatically figure out. It's a skill that we can build. And through education and school, it's something that we do. I think if I expand a little bit closer, or pull in a little bit, I guess I should say, is a part of this lifelong learning and the things that we teach in school is that we should also teach students how to be effective problem solvers. And being an effective problem solver will help you be a lifelong learner. It will help you be a team player, a collaborator. It'll help you figure out academics and foster greater critical thinking and things like that. So it's, again, an immensely important subject or content area that we should bring into school. And that tangent conversation is how we get back to design thinking, of where does design thinking fit into the conversation. It can fit into the academic side of things, the collaboration side of things, the play side of things, but really it's providing students a chance to become more effective problem solvers, more effective critical thinkers, and also, again, become more effective lifelong learners. So they will find and continue to find success even after their educational experience. So with that, let's dive into design thinking a little bit more. I'm also keeping an eye on the chat, so I'm going to try to answer questions and things as we go, but I'll definitely save time for a Q&A, and I appreciate the praise for the helmets and things like that too. Much appreciated. So anyway, what is design thinking? It's an iterative problem-solving method through creative thinking and a human-centered approach to designing solutions. That is a core definition. Of course, we're going to dive in a little bit more about what that actually means, but it's not necessarily an education concept. Design thinking is very active in industry, right? If you are a product designer, especially if you're a product designer for some type of human interaction, right? Something that humans interact with, whether it's ergonomics or furniture or things like that, it's a big aspect to how the products we buy and use every day are created. And this is a personal philosophy that I love to carry through into my classes as well, because there's a lot of benefits of what it will provide to your students. It will increase student engagement. It will help find more intrinsic motivation. And as I've already said, build stronger problem solvers, critical thinkers, foster collaboration. One of my most important things I want to foster is empathy. And again, that helps us create lifelong learners. And bringing design thinking into your classroom, even if it's not, let's say, an engineering problem solving class, can help you build all these things and again, help students grow as creative thinkers as they go through. So let's talk about how. If I come back to the definition, right, it's an iterative problem solving method through creative thinking and a human-centered approach to designing solution. Let's dissect this a little bit, right? First, focusing on iterative problem solving method. What does that mean? Well, typically this means that you're going about solving problems through some type of iterative process, often described as a design process or an engineering design process or an EDP, depending on what acronym you'd like to use. To be clear, this is not the engineering design process. This is just one that I like to use, or I did use when I was teaching at the middle school level, where you can see that we start by identifying the problem, then we'll brainstorm solutions, we'll construct some type of prototype or model, we'll test to see if that works, and then we'll reflect to see how well it worked and how we can improve. And if time allows, we start over and we redesign it and we improve. And there are oodles of design processes out there. Sometimes you might call them product life cycles. You might call it the scientific method. There's lots of different problem design solving processes out there. And you can certainly choose the one that has the language that relates to your students more or fits into your classroom more effectively. For example, the one on the left is a slightly smaller loop, and the one that I typically use at the elementary school level, where it's still identifying a problem, designing a solution, evaluating and analyzing. So the same big ideas, but perhaps a little bit more understandable and relatable to a younger student. And I would use an even more broad design process when I'm teaching my college students at this point, right? So an iterative problem solving method means that you are not just going in and saying, I'm going to solve a problem and it's going to work and then I'm going to move on. That's not really how it works. You might attempt to solve a problem, see what you did well and where you can still improve, and then make changes and improve and expand on that. And that's the iterative approach, right? And this isn't just prototyping a product. Let's say that students are creating a research paper, or they're designing a website, or they're making some type of scientific lab where they're testing the collision of cars or something like that. They might write a paper and then they want to proofread it, right? And they want to make it a little bit better. And then they maybe get a peer review to get someone else's opinion on their paper. That's an iterative approach to creation. And that's what we're talking about here with design thinking, at least with the first component of design thinking, an iterative approach to problem solving. The second component to design thinking in my little definition here is creative thinking, right? So this one might be a little bit more familiar to a wider range of educators, of course, what creative thinking is, but how do we foster higher levels of creative thinking? And I think the first thing we should do is teach students how to brainstorm. I also find, as somebody who's been teaching students how to use the design process for a very long time now, that this is without a doubt the hardest step of the design process, in my opinion. Meaning that if you learn how to use tools and machines like 3D printers and whatever, you can make a prototype with a 3D printer. But coming up with different ideas to 3D print, to brainstorm, that's tricky, especially because it's in our nature to come up with an idea and then want to run with it, right? We have to take a couple steps back and dive a little bit deeper and think about all the possibilities that we can within the time limits that we have. Because what if our idea fails? What if it doesn't work right? What if we realize that we ran out of materials or time? If we have multiple ideas, if we brainstorm more thoroughly, we can develop more successful products down the road. And I personally love to teach brainstorming through sketching or some type of storyboarding, planning. But there's a lot of different ways to brainstorm. And again, this is relevant to a lot of different types of subject areas. Another big component of critical thinking is teaching with constraints. And when I do a professional development workshop on designing design challenges, this is often one that usually I get a little bit of pushback for, meaning that if I'm telling teachers to do some type of open-ended design challenge where their students make a thing, right? They'll often say, well, I don't want to constrain them on materials because I want it to be open-ended. But here's the thing. If you ask your students of any level, or even you sitting in this meeting with me right now, if I say, go design me a thing, and you'll say, with what? Anything. For what? Anything. Most people will really struggle to get started with that. That's kind of difficult. So if we give students some constraints, whether that's time, an imaginary budget, a list of materials, a certain amount of tape, a certain amount of paper, yes, you can use hot glue, no, you can't, etc., right? It will actually promote them to get a little jump start because now they know what they have to work with. They're still going to design a creative solution around those constraints. In fact, they'll actually have to work a little bit harder to implement their creativity with constraints than if it was truly vastly open-ended. And again, it will help students get a jump start on that as they go through. So teaching with constraints not only helps you as the educator, because you know how to prepare for your lessons, you know what you need, it will also drastically improve critical thinking. And it's way more real world. If you go work for a company somewhere, you're not going to walk in and they're just going to say, yeah, make a thing. No. You're going to have a budget and a time limit, and maybe it needs to incorporate sustainability or local materials. And we can challenge our students in the same way. Another big thing that I mentioned earlier a little bit is foster collaboration. Working as a group, working in a team, or even doing peer reviews, where even if you work alone, getting feedback from someone else is a great way to bring in greater critical thinking. You know, we all think a little bit differently. We all have different perspectives. We all come in with different prior experiences, and we have different interests and passions as well. So if students have a chance to build on those, then they can learn from their peers and share their knowledge with their peers as well. And also encourage experimentation, right? Give your students a chance to fail a little bit. Don't always give them the right answer. Let them find it in a safe way to do that, meaning that let students investigate, let students see things go wrong. I often do tower challenges and catapult challenges and car challenges, and students are say, well, my tower is going to be this tall and it's going to work really, really great. I'm like, okay, sure, give it a go. Even though with my experience, I'm like, there's no way that's going to stand. But I know it's a safe thing and we're not going to waste materials or too much time. And my students are going to remember that experience way more because they had a chance to try it and see it not work than if I just told them, no, that's never going to work. Come up with something else. So encourage experimentation. All of these things together will help students overcome their fear of failure, which is, again, just something natural. All humans, are afraid of failing. We're afraid to make mistakes. But if we can overcome that in a safe educational environment, we will become more effective problem solvers. I also find at the youngest level, when I work with my elementary school students, they're not really afraid of failure. That happens when students get older. An elementary school student will go in blind and be like, yeah, it's going to work fine. I'm going to love it. It's going to be great. My son right now, he's 17 months and he's not afraid of anything. He'll jump off whatever it is. So I got to keep an eye on him. But So let students build on that, bring that in, and let students overcome their fear of failure at a younger age and carry that through as they get older. So now let's bring on to our next component of design thinking, which is a human-centered approach. And I think there's two big ways to make learning human-centered in education, and that's incorporating empathy and making learning relatable. So incorporating empathy can be done in a lot of different ways. It's essentially challenging students to design a solution for someone else. And that could be a pet. I love bringing my dog into the conversation when I can, helping design some type of slow feed system because he eats too fast. It could be for your community. So let's program robots to go deliver groceries in our local community. It could be something like designing a video game controller for somebody with a disability, or designing a prosthetic for somebody with a disability. And it could be much simpler than that. It doesn't always have to be solving the world and fixing everything, but allowing students to see that their learning, their skills can actually help someone else, not just them. And that's incorporating empathy in your conversations. I actually just did this project with my college students, where, as I mentioned, I'm teaching future STEM and technology educators, right? So these are college students that are going to become K-12 STEM or tech educators. And I told them that if you are a technology educator, you're probably going to be teaching with some type of laptop of some type, and that's going to have a touch screen and a trackpad. But you also might find that you have students who can't access the technology using a touchscreen or a trackpad. Maybe they have some type of motor disability. Maybe they're unable to have clicking and typing and all these things. So I challenge my students to design some type of computer mouse for somebody with a motor disability. They had to research the different motor disabilities that are relevant and applicable for students at the age group, and then design some type of computer mouse to allow them to engage with technology and their lessons, even if they have that motor disability. And because we're STEM educators, we brought in some circuits and prototyping and some computer programming and stuff too, because that's of course ways to enrich that. Making learning relatable, well, we kind of already talked about doing that a little bit already, but it can be as simple as, how do we help our school or our community, right? Maybe they are engineers and they've been challenged to do something. So they're thinking about, ooh, I have a career. I'm an engineer. I'm a professional. And this is what engineers do. Maybe your school needs help designing something. Maybe your neighbor wants to know something. Maybe they've been hired by a big company like NASA or IEEE or something like that, and their job is to do this. Maybe they're talking to Samantha, who's a computer programmer, and she's trying to figure out how to do something. Or maybe their town's preparing for a winter season. It could be hypothetical. You could actually try to connect with organizations like NASA, who supports education, and bring in a real world challenge. And now students are seeing how their learning impacts a larger community than their own little perspective that they have. Not just helping them, but helping their colleagues, their school, their town, their world, right? Making it relatable. It's not that we're always going to find a direct way for students to say, like, yes, I love this. But if they figure out the fact that what they're learning in school, the skills that they're learning in school, is being used by somebody somewhere, then that might make it a little bit more relatable and relevant for them. And then the last part of this definition is designing solutions. Now, I think we've already mentioned the word prototype a little bit. I saw it in the chat a little bit here too. So prototyping is an early iteration of a product, basically some type of draft that might resemble the final product, or it might not. It might not be made of the same materials. It might not work the same way. And we often call prototypes some type of physical thing. So here's a prototype from one of my STEM classes. It was designed by a girl who taught me that detangler is a thing. I didn't know that. And she designed this little brush that had the detangler built right in. So she could kind of squeeze the detangler out as she brushed her hair. And she did that through a design process, as we talked about earlier. But a prototype can also be some type of paper, whatever it might be. It doesn't have to necessarily be a physical product. It could be a website. It could be an app. And if time allows, I love to let my students actually do multiple levels of prototype, go through that iterative approach where maybe they make a prototype out of Play-Doh or cardboard, or they design multiple models in CAD. Somebody asked if I use Tinkercad, and I sure do. There's a Tinkercad screenshot right there on the screen of a student making a couple different prototypes in Tinkercad before they make it. And then after they do those rough prototypes, then they expand it, they refine it. So design thinking definitely fits well within the problem-based learning and the project-based learning world, problem-based learning and project-based learning domains, which is where I spend most of my teaching career, right? But it can expand beyond that. It can fit within the science classes where students are making some type of model, some type of testing environment, some type of plant watering system, some type of ecosystem, some type of physical application like a catapult or a Newton crash car or something like that. It can fit in ELA. You could use some type of storyboard outlining template to help them design their stories, draft their papers. They could design, instead of writing a paper? Can they write copy for a website? Can they design the pages of an informational app? Can they make a poster? Can they make a video game, right? If we're having students design a story with a protagonist and an antagonist and a plot and an objective and a villain, isn't that also what a video game is, right? So can we bring that in instead? Or math. One of my favorite things to teach in math is probability because I find it to be very hands-on and I enjoy that. So can we make probability testing carnival games, or can we program a microbit to be a die or heads and tails to test our probability theories? Or can we do Bungee Barbie, which is a classic project? And I'm definitely dating myself a little bit there. If you don't know what Bungee Barbie is, definitely look it up. It's a fun one. It does involve ladders or roofs, though, so be cautious. Or social studies, where students might be designing some type of ancient tool or maybe making some type of ancient cylinder seal to press out a story, something like that. So we can bring in design thinking and prototyping in virtually any subject as you go through. And just to show that, here's an example activity without design thinking. After outlining your opinion on the removal of parks of wildlife, draft a 5-paragraph essay to argue your opinion towards those who may disagree with you. Right? That's just an example. If you're teaching students some type of opinion-based writing piece, this is a design brief that they might have. Let's incorporate design thinking. The nonprofit you work for is trying to protect our local parks and wildlife. To help, we must share our opinions on this topic to argue these points to those who may disagree. So now we're telling students that they work for a nonprofit. We're giving them some type of real world career aspect that they might be able to apply their current skills for. We're telling them that they're helping their parks. They're protecting their local parks in their town. People want to take that away. Can we help that? And maybe it's not just a 5-paragraph essay. Maybe it's an essay for your local newspaper, or posters to inform your neighbors of this issue, or a web page, or an app, or whatever it is, right? There's a lot of different ways that we can actually design this as we go through. So design thinking is an iterative problem-solving method through creative thinking and human-centered approach to designing solutions. And as I've already said, there's a lot of ways that we can incorporate this. If you want a simpler definition, think of it this way. Design thinking in education is finding the why so students can create the what. I, as an educator, always strive for the fact that I never wanted my students to ask me, why are we learning this? I wasn't ignorant enough to think that everything I taught them would be immediately relevant and they would love it. But I, as a student, and I wasn't a very good student, would be like, why is this important? What am I doing right now, right? I wanted my students to know that the skills that they're obtaining, the experience that they're obtaining now is relevant to somebody somewhere. I hope that they love it, and I hope it's relevant and relatable to them. But I want them to know that it has value to some profession, some future. Somebody needs that. And then I wanted them to design a solution using that scenario as we go through. And perhaps you as the educator provide the why. Perhaps as your students get older, they find the why. They identify that problem on their own. But the most important thing, if we haven't already covered it, is reflection and redesign. Always provide your students with the chance to look how they can improve. Look at how their knowledge could be used to improve their designs. If you have the time, have them recreate something, which time is never something we have in education, I know. But if they can sort of redesign their prototype, even if that's through a sketch or a CAD model or an exit ticket or a class discussion, always show them that, hey, you did a great job. You made something awesome, but you learned a lot along the way. And if I asked you to do this again, what new knowledge did you obtain that would help you do a better job? And that again helps students overcome their failure and foster greater engagement, motivation, problem solving, all of the above through design thinking. So creating effective problem solvers prepares students for their future careers, even if those careers do not yet exist. And there's a lot of things we do with students in school. We provide to them in school, but academics can't necessarily do this. Academics and standards will change. Being an effective problem solver will adapt as they go through for whatever that career might be. But wait, there's more. First off, thank you so much. I am going to open up the floor to a Q&A in just a moment. I showed you a lot of really cool things in this presentation. At least I hope you think they're cool, like projects and lessons. And I referenced a lot of stuff very quickly from my teaching career. Every single thing I reference, all my lessons, everything I know about teaching STEM and technology education is on my website. So definitely feel free to check that out. You can find lots of great resources on there that I kind of referenced and glossed over pretty quickly. And of course, feel free to reach out anytime. You can find me on the socials. You can reach out if I can support you. And definitely thanks so much for tuning in with this presentation. So I think I'll open up to a Q&A and hopefully I can get some help doing that. And thank you again, everybody. Much appreciated.
Hey, Jason, you have quite a few questions. Do you want me to pop them over for you?
Yeah, go ahead. If you want to pick some,
All
that would
right.
be
There's a
great.
couple of great
Thank you.
ones. I guess I'll go from, oh, there you're getting a lot of good feedback.
Oh, thank you, everybody. Much appreciated.
Yeah. Let me see here. Let's share this one. So this one is, what are some of the best ways teachers can integrate empathy into their teaching?
Yeah, that's awesome. That's great. I think that this is. I don't believe empathy should be a lesson or a unit. I think it should just sort of be interwoven in all aspects that you do. Right. So consider whatever the project might be. I'll be specific and I'll say in STEM. Let's say that I'm challenging students to learn about structures and forces, and they have to make some type of, I don't know, catapult or whatever it might be. Instead of me saying, "Hey, let's design a catapult," because you're learning about structures and forces, let's say, "Hey, you live in medieval times and you need to help people, right? Defend your village. Let's design a catapult for that reason." It could be as simple as a perspective. Or again, let's say that you're an ELA teacher and you're challenging students to create some type of non-fictional piece. They're not just making a non-fictional piece, they're making a non-fictional piece to potentially go teach somebody about something. Maybe they're making something for their own school library, right? Take those skills and just allow students to use those skills to help somebody somewhere. If it can be real, great. If it can be hypothetical and simulated, that still changes the perspective and allows students to see how they could be more empathetic in what they create.
Great. All right. I think we'll take a couple more. We've got a few more minutes. So, all right. Let me push this one over. So, can STEM education help apply a human centered approach when designing real world solutions? If so, what process or framework can educators use to guide them?
Yeah, absolutely. I think, STEM education well, we could spend a whole another 30 minutes talking about what I think STEM education is. But I think the core idea is that students aren't necessarily learning in silos, right? They're not just learning science concepts, they're not just learning math concepts, they're not just learning how to be problem solvers. They're sort of learning how to be problem solvers while using math skills, using science phenomena, right? So it's interweaving, it's integrating the core STEM subject areas, because if you're a STEM professional, you're not just never doing math or never using technology, you're doing it all together, right? So if we're teaching students how to be, let's say, or teaching them how to apply a human-centered approach to design, where maybe they are considering human needs, that empathetic piece, and they are looking to design a real-world solution to help people, like some of the prosthetic type things I mentioned, yeah, let them bring in some science concepts. Let them choose the right type of material. Let them, do a little bit of math. Are they collecting data to determine if they've tested and evaluated their prototype solution effectively? Does it work 9 out of 10 times, right? So can you foster some integrated interdisciplinary learning in that? Absolutely.
Awesome. Great. Great. All right. Here's one. We'll see if we can get maybe one, maybe two more. Hold on. Let's see. Here we go. I teach the same way, so I feel validated by you saying this. Do you have any resources, studies which can connect these methods to impact on youth learning outcomes?
Yes. First off, thank you. I much appreciate that. I would definitely check out my website, mrerdreich.com. And if you go to resources, there's about a bajillion things on there. I don't even know, like 1,500 things. It just keeps growing. But there are different types of you have standards, you have outcomes and objectives for learning, right? There are a lot of different types of guidelines that would define that. I think there's some really great professional organizations that provide those types of learning outcomes for students specific to, let's say, the design thinking approach, the problem solving approach. I'm thinking like IEEE's try engineering philosophy, or ITEA has their standards for technological and education literacy, and there's ISTE, and there's so many great things. I think if you go to my website under like curriculum and inspirations for design, there's a lot of those types of things that might help you connect those concepts that are pretty great.
All right, great. Well, I think we'll take. There's a bunch. There's so many. I don't think we'll get to them all, Jason. But here's
Well,
another one.
definitely, folks, find me and reach out. I'm happy to continue the conversation after this session.
Yeah, here. I guess we can close on this one because we're at the time. What is the major hurdle that you've encountered in teaching design thinking, and how have you overcome it?
That's a tough one. The major hurdle I've encountered, there's been so many major hurdles. I think for me, I come with a lot of industry experience, right? So I've come into my class and I've definitely maybe been a little bit ambitious with the types of concepts I've challenged my students to do. Like case in point, I've gotten patents and things like that in the past. So I kind of came in, I was like, students, you're going to get a patent, right? And that was maybe unfair. And maybe also a little bit too tangent, where I started to fall out of the perspective. So design thinking is a very, very strong philosophy for product design in general, and it's so broad. in education, focus on the fact that we're using design thinking to make students who are more effective and empathetic problem solvers, right? And allow that design thinking philosophy to not completely overhaul the key academic content and subjects you're trying to teach, but let it just be a mindset, a philosophy. It could be a phrasing in how students engage with that. Because if you do a deep dive in design thinking philosophy, you might start to leave not education philosophy, but what's viable to do in an education setting. And I've definitely made that mistake a few times. It's worked out, but it maybe was a little bit ambitious on my side.
That's great. Jason, thank you so much. This was fabulous. There are so many questions. If you see the chat, you're getting a lot of love,
Much
and
appreciated.
talked
Thank you
about
very
how
much. Yeah,
practical this session was, and great resources that you're. I definitely recommend everyone go to Jason's website, see all that he has. If you're looking for further information, you can contact him directly over there. But we will try and follow up, Jason, with some of these questions. To you have
for
so
sure.
many that we need to answer. So
Of course. Thank you so much. Much
thank you
appreciated,
so much.
Donna. And
We
thank you
appreciate
again
you.
to, yeah, my pleasure. And thanks again to IEEE. I hope everyone enjoys the rest of the summit, you folks.